This is your quick review to retake your matter quiz. Once you complete this Edpuzzle with 100%, you can complete the review at the end of the Edpuzzle. Once you do that, show me your progress and you will be allowed to retake your matter quiz. So our goal for this particular review is to learn about what matter is, what the definition of matter is, and examples of matter. And then we'll talk a little bit about atoms. We'll talk about the periodic table, how each element on the periodic table is its own specific and unique atom. And we'll go into more details about that. So, first off, matter is anything in our universe that has mass and takes up space. So, mass is a unit, it's a measurement that we use to describe how much matter there is. So, a lot of times we measure mass in a unit called grams. It's a very similar measurement to weight, which is why you have an image of a scale here. Okay. Volume is the other requirement for something to be considered matter. So, volume from math class, maybe you've learned how to measure the volume of something like a cube, like by multiplying length, width, and height. Volume is just the amount of space an object takes up. So, we can often calculate volume. And we can also measure volume by doing things like displacement. Displacement is where we would drop the object into maybe a beaker of water and see how much water it moves, how much the water level rises. And when we do that, it gives us an idea of how much space the object or substance takes up. So if an object has mass, if you can weigh it and it takes up space, then it's considered matter. So just about everything in our universe is matter, but there are some non-examples. Our non-examples are things like light, heat, and sound. Those are all examples of energy. So energy is not matter. It is something different from matter, which you'll be studying coming up very, very soon. So as long as it isn't one of these three things, as long as it isn't another form of energy and it has mass and it takes up space, it is matter. Okay. All matter is made out of atoms. Atoms are the building blocks of matter. They are the smallest unit of an element that can't be broken down without changing what the substance is. Okay, so we cannot break down an atom of carbon without changing that substance. It will no longer be carbon. So it's another key idea about matter. All substances in our universe are made out of atoms. Remember that atoms have three parts. We've got protons, neutrons, and electrons. In the center of an atom, we have the nucleus. This is the nucleus here, and it contains two of the different types of particles. The positively charged particles are the protons. The particles that are in this particular model colored green, those particles are no charge, and particles with no charge are the neutrons. They have no charge. Electrons are the third type of particle. They are not found in the nucleus. The electrons are found in the orbitals or the electron shell. Okay, and they have a negative charge. So electrons are always found in the electron cloud in this area outside of the nucleus, and they are constantly in motion. They fill the shells outside of the nucleus from the inside out, and they have a negative charge. Really important thing to know about atoms is that each element is its own unique type of atom. So if we were talking about the element iron, iron is its own unique type of atom. It's different from every other element. And what determines what the element is, what the atom is its atomic number. So the number of protons in an atom is what determines what element that atom is. So this is also called the atomic number. So looking at the periodic table, if I were to look at any particular tile or square on the periodic table, I could learn a couple things about whatever element that is. The first thing, there's a symbol, and the symbol is usually one or two letters, And sometimes they're really easy to understand because the symbols are based on the language that most of us are probably familiar with in this classroom, which is English, but sometimes the symbols are based on other languages. This particular symbol is based on another language. So the symbol for iron is Fe. The atomic number of iron is 26. So that tells us that every atom of iron in the universe has 26 protons in its nucleus. Okay. In addition to that, so we always see the element's name, and then the last thing down here is the atomic mass. And the atomic mass is the number of protons and the number of neutrons in the nucleus of iron, of every iron atom. Now, that does have a weird number here. It's not a whole number, but that's because of a kind of higher level science concept that you'll learn in chemistry class in high school. But what we would know is that iron mostly has 56. Almost every iron atom has 56 if we rounded it. Protons and neutrons when you add those protons and neutrons together. So 26. Actually, that's not right. Sorry, so 26 protons plus the number of neutrons, which is going to be in this case 30, to end up with the mass of iron, which will be 56. Hopefully that math was right. My brain's not working quite right today. All right, so that is basically what you need to know about atoms and the periodic table. The last thing that I want you to know is that we can put atoms together to form molecules. So sometimes elements are an individual atom. Sometimes those atoms of the same type are put together and we form molecules. So we could have multiple atoms put together and form a molecule. For instance, these two things right here are probably millions of atoms put together to form different molecules. And what we can find when we do that is sometimes elements can look different just by how the structure of their molecules are put together. So believe it or not, both of these substances are the element carbon. Okay. So interestingly, these substances don't look anything alike, but they're made out of the exact same element. This is only made out of carbon, and this is only made out of carbon. This is structured differently. So the carbon atoms are put together much differently for this version than they are of this version. So sometimes the same element can look very, very different based on how all those atoms are combined. All right, that's all for this mini lesson. Go ahead and give the review a shot. After you have taken that, show me your progress, and I will let you know if you are able to retake your quiz. Good luck, and I look forward to seeing your progress.